Okay, welcome to this video where we will be attempting chapter 3. So in this video, we'll be going through chapter 3 of our ICT textbook. So chapter 3 is about memory and processors, about the storage devices in your computer, and also about the processor in your computer. Now, let's just quickly go back to what we have completed so far. So far, we have completed chapter 1. So in chapter 1, we saw various digital devices, the function of each of those devices. Then we also went through peripheral devices, input devices, output devices. Okay, so we went through all that in chapter number 1. In chapter number 2, we went through the programs that run on a computer. Okay, so chapter number 2 was about software. It was about the various programs that are stored on a computer. What are their functions? How do they work? Okay, that is what we looked at in chapter number 2. In chapter number 3, in this particular chapter, we will be going through the storage devices and what is the function of a processor in your computer. Okay, right. So moving on, over here, computer memory can be broken down into two main categories. Okay, so you have primary memory and you have secondary memory. Okay, so under primary memory, you have only two storage devices, which is your RAM and your ROM. Okay, so what is the function of RAM? What is the function of ROM? These are all coming on later on. Okay, but for now, what I want you to understand is you have computer memory, you have primary memory, and you have secondary memory. And under primary memory, you have two storage devices only. Okay, only two storage devices. However, all other storage devices in your computer will come under secondary memory. Okay, just give me a second. Okay, so under primary memory, we have only two storage devices and all other storage devices will come under secondary memory. Now, sometimes in past papers, just to confuse you, they would say internal hard disk. Is it primary or secondary? So students think, okay, it's internal, it should be primary. No. Only RAM ROM come under primary. Everything else, whether it's internal or external or what, it doesn't matter. It comes under secondary memory. Okay, right. So moving on. So we will first look at what primary memory is, what is a function of primary memory. Then we move on to RAM ROM. Then we come on to secondary memory. We will go in order. Okay. So right now, let's see what primary memory is all about. Okay. So over here, either you can call it primary memory or you can simply call it main memory. Okay, one of the words, both are completely fine. Now, an important feature, something very, very important about primary memory is that it can be accessed faster than secondary storage. Okay, so both these devices over here, and unique feature about them, a unique thing about them is that they can be accessed much faster. Accessed as in reading data from it and writing data to it happens much faster than any storage in secondary memory. Okay, that is an extremely important feature to keep in mind. Okay, so what is the since primary I'm sorry. So what is the reason behind primary memory having such a great read-write speed? The reason behind is that since primary memory is generally smaller in memory capacity, since primary memory is so much more smaller in memory capacity, finding files inside it is much faster than in secondary memory. Okay, so there are other reasons as well, but the main reason why secondary memory is slower than primary memory is because primary memory has a much smaller memory capacity than secondary. Okay, let me just explain it to you this way. If you were to consider a two-story building, okay, a building that has 2 floors and a building that has 4 floors, or let's say, for example, 5 or 10 floors, let's make it a much easier example. A 2-story building versus a 10-story building, okay? So finding something inside a 2-story building, say, for example, I tell you to find a document, okay, which is placed somewhere inside the 2-story building. And the same document is also placed inside the 10-story building. And if I was to ask you, which one would take you a shorter time to find? You would say, well, finding a document inside a 2-story building will take a much shorter time because you have to only go through 2 floors. On the other hand, the other building has 10 floors. You have to go through 10 floors looking for the document. Okay, so that's going to take a longer time. The same concept, I hope it was clear, the same concept we apply in primary memory as well. Primary memory, the main reason you can access it much faster is because it has a very much smaller memory capacity. Okay, right. Now, under main memory, under primary memory, it consists of two parts. Okay, so you have RAM and you have ROM. Is it clear? So primary memory has two parts, RAM and ROM. That's it, nothing else. Okay, nothing else comes under primary memory or main memory. Right. Let's move on. So over here, we are first going to be talking about the RAM chip. Okay, so we are first going to be talking about RAM, which is this. Okay, we are first going to be talking about this storage device. Okay, so over here, I have showed you a few pictures. However, guys, look, this is a RAM for a desktop computer. Okay, this is a RAM chip for a desktop computer, which is why it's quite big in size. Okay, and this is a desktop motherboard. Okay, over here we have a desktop motherboard, and you can see there are two RAM slots. Okay, there are two RAM slots. So you can see they're inserting a RAM into one of the slots. Okay, and over here you can see the internal structure of a CPU. Okay, right. So we have seen a few pictures. Okay, but keep in mind, guys, when you go into a tab, when you go into a smartphone, the RAM chip is very much more smaller, very much more smaller. Okay, since this is a desktop, it's a bit big in size. Okay, right. Next, data files of a software. Okay, so program files of a software are loaded into the RAM from a computer's secondary storage. Example, the hard disk. Okay, so let me put it to you this way. When you open up, say for example, Adobe Photoshop, okay, say for example, you open Adobe Photoshop, the data files that are required to open Photoshop are taken from your computer's secondary storage. Is it clear? Over here it says it's taken from your computer's secondary storage. So for example, on your hard disk, you will have Photoshop's data file stored. Is it clear? So when you double click on Photoshop, the data files are taken from your computer's secondary storage and given to your RAM. Is it clear, guys? Are you with me up to this point? So when you request for a software to open, you go and double click on Photoshop, or you go and double click on Google Chrome, or you go and double click on Microsoft Word, any software that you go and open, the files have to be loaded. So at the moment, the files are in your computer's secondary storage. This is where they are. Okay, all files are in your computer's secondary storage. So the moment you open a specific software, the files are taken from your computer's secondary storage and given to your RAM. Okay, right. Next what happens is the processor. So we have something called a processor, which we will discuss later in this chapter. Okay, one of the last things that we will discuss is the processor. So what I want you to remember now is the processor then fetches software instructions from the RAM. Okay, so the software instructions that the RAM took will now be given to your processor. And what does the processor do? The processor executes them. So what do you mean by execute? Execute basically means converting data into information. Okay, that's what's happening. Okay, so I'm gonna show you guys how it happens on my computer itself. So give me a second. Okay, so I'm going to go to my computer. Over here, I have my computer. And this is my secondary storage. Okay, local disk C as in this is my secondary storage. So over here, I have all my softwares stored. Okay, all my softwares are stored. So if I come into program files, you can see over here, if I come into Adobe, or Adobe. Over here, we have Adobe Photoshop. So these are the data files for Photoshop. Is it clear? Now, in order to open up Photoshop, these files have to be converted into information. They have to be executed by my computer's processor. Okay. Now, right now, they are on my computer's hard disk. Now, when I come and open up Photoshop, when I come and click on Photoshop, what's going to happen is these data files are going to be taken from my secondary storage, which is my hard disk right now, and it would be given to my RAM. Is it clear? And thereafter, my RAM would give it to my processor to convert this into information. Okay, right now it is data. I don't understand any of it. But once it is converted into information, I would understand, because then Photoshop would open, the menu bar would be there, the tools would be there, the layers would be there, you know, that I understand. That is information. Okay, guys. So I hope up to this point, it makes sense. Okay, so over here, I have given you a diagram as well. You can see you have your storage device. Instructions are taken from your storage device and given to your RAM, and then your RAM will give it to your processor for processing. So after your processor processes it, okay, after your processor processes it, the next step will be, what would be the next step? You would have a output. Okay, so I'm writing with my trackpad, so it's not very clear. Okay, so I hope this cycle or this sequence is clear. Okay, so when you, for example, let's say when you switch on your computer, the operating system has to be loaded. Okay, so if you look on my laptop, this is where I have my operating system. Can you see in local disk C, in my hard disk, which is my secondary storage, this is where my operating system data files are. Data files. Okay, these files don't make sense to me. Now, when I switch on my laptop, operating system has to be loaded. So the RAM will collect these files from my hard disk. Is it clear? It will collect these files from my hard disk and give it to my processor to process. So then my processor will start processing, converting all this into information. Then what I see is, I see the wallpaper loading, the icons appearing, date time appearing, then the taskbar appears, one by one as it's processing, things start appearing on my screen. Okay, guys? Right. Next, guys, what we need to keep in mind is RAM is volatile. Okay, 1 second. Your RAM is volatile. This is an important word. A feature of the RAM or a characteristic of the RAM is that it is volatile, meaning that it cannot store data when it has no power. Okay, so the moment your computer switches off, okay, say for example, you're using your device and there is a power cut. Once your device powers off, whatever data was there in your RAM, is completely lost, is completely deleted, is completely erased. Is it clear? Because the RAM is volatile. Okay. Once the power is taken off, it loses all its data. Okay. So that is what we have explained over here. Okay. So guys, this volatile is a characteristic of RAM. Okay. If they ever ask you list the characteristics of RAM, an important characteristic is it is volatile. Okay. Right. Moving on. The next thing it says is the RAM is also used to store programs that are in use or running in the background. Okay, now say for example, when you have your device running, or let's take my laptop as an example. Right now, I have multiple programs running. Okay, so for example, if I press Alt Tab, you can see I have all these programs running at the moment. Okay, so when a program is running, when a program is working in the background, that particular program will be stored in your computer's RAM. Okay, when there is a program that is currently running, so right now, for example, I have Zoom running, I have WhatsApp running, okay, I have Windows File Explorer running. Okay, so programs that are currently running in the background, programs that you are currently using, for example, I have PowerPoint that I'm using right now. So programs that are running in the background or programs that you are using right now will also be held in your RAM. Okay, until you close it. The moment you close it, it will be removed from your RAM. Okay, let me show you one more thing. Control Shift Escape. If I press Control Shift Escape, shows this is my memory, and my memory is right now 66% full. Okay, right now it is 66% full of what? Full of PowerPoint is taking 103.9 MB. Task Manager is taking 24 MB. WhatsApp is taking 67 MB. So these programs that are currently running in the background, okay, my RAM is holding it for me. Okay, which is why, guys, one more thing, say for example, my device switches off. Say for example, if my device switches off and if I switch it on again, it starts from the beginning, isn't it? It starts from the beginning. The reason it starts from the beginning is because when it was switched off, all the data in the RAM is lost. Okay, so when I switch it on again, I have to open all the programs again from the beginning. Okay, because the RAM is volatile. Once the power is knocked off, it loses all the data. Okay, right. So moving on to the second point, guys, it says, so the more RAM that is available, the higher the capacity of the RAM, the more programs can run at the same time. Okay, so if you have a 16 GB RAM, you can definitely have a lot more programs open, a lot more programs running at the same time than with an 8 GB RAM. Okay. Now, when the computer system does not have enough space in RAM, the operating system creates virtual memory by using an area of secondary storage. Okay, now say for example your RAM is full. Okay, your RAM is full. Okay, there is no more space to hold any more programs. So when this happens, when your RAM is full, when this happens, your computer will then instruct the secondary storage, which would be your hard disk, for example. It would instruct your hard disk to also behave like a RAM. Is it clear? Okay, so when your RAM is full and on top of that you go and open another program as well, then the operating system would tell your hard disk, well, now you also have to behave like a RAM. Okay, but there is going to be a major problem over there. Accessing data from secondary storage is much slower. Okay, your secondary storage is 500 GB, is 1 terabyte. For example, your hard disk, it will be 500 GB or 1 terabyte. So finding files from 500 GB storage device or from a 1 terabyte storage device is going to take some time. Okay, not some time, it's going to take quite a while, isn't it? So when virtual memory is created, the moment virtual memory is created, you're going to notice your computer becoming very, very slow. Okay, sometimes it gets so slow that your computer gives a message saying not responding. Okay, that happens. Okay, so the user will notice a big decrease in system performance when the processor has to access instructions from virtual memory. Okay, so when virtual memory is created, immediately you will notice computer has become very, very slow. Okay, when programs or files are closed, they are removed from RAM. Okay, as space in RAM becomes available, active programs are moved into RAM from virtual memory, and this will improve the performance of those programs. So if you're having a problem of where your computer is very slow, it's getting stuck, not responding, do check. Do you have too many programs open in the RAM? Okay, so try and close programs that you are not using. Sometimes we have this habit, we don't close, especially on smartphones. We have apps after apps running in the background. Okay, so then the RAM gets full, then the phone gets slow. Okay, so try to close. When you close an app, it's removed from the RAM. So then there is some space available in the RAM for newer programs. Okay, so one way to improve the performance is keep closing programs that you are not using. Keep freeing up space in your computer's RAM. Okay. Now, a user can add more RAM to a system, but only up to the maximum supported by the computer and operating system. So guys, yes, you can increase the capacity of the RAM. If you look at this picture over here, you can see there are two slots. Okay, you can remove this. For example, let's say there is a 4 GB RAM. You can remove this and put an 8 GB RAM, or you can simply add another 4 GB RAM and make it 8 GB. Now, this is possible in almost all desktop computers. It is possible to upgrade the RAM. Okay, so generally RAM can be upgraded. However, when it comes to certain devices such as a smartphone, such as a tablet, you may not be allowed to upgrade the RAM. Okay, they may seal the device and give you. So then upgrading the RAM will not be possible. Now, for example, look at almost all smartphones, upgrading of the RAM is not possible. Okay, however, desktops and certain laptops, upgrading of the RAM is possible. Okay, right. So adding more RAM can improve the performance of a computer system when the user is using multiple files or programs at the same time. Okay, right. So we have now learned the function of the RAM. So remember guys, the RAM has two functions. Number one is loading programs from the secondary storage and giving it to your processor. That is function number one. And function number two is holding programs that the user is currently working on or is running in your computer's background. Okay, these are the two functions of your RAM. Okay, so then features or characteristics of the RAM. Number one, you can say it is volatile, which means it loses its power. It loses its data when the power is switched off. Number two, it can be upgraded. Okay, the capacity of your RAM can be upgraded. Okay, or if you want to be very, very safe, you can say like this. For certain devices, such as a desktop and laptop, the capacity of the RAM can be upgraded. Okay. Right. Moving on to the next slide. So over here, there is a question, and this is a question from the 2021 past paper. Okay. From the 2021 past paper, it says, explain one benefit of increasing the size of RAM in a laptop. Okay, so increasing the RAM of, now guys, look here, the keyword here is explain. So you have to give your point and go on to explain it. So for example, if I was to explain it, I would talk about the fact that more programs can run in the background when there is a larger amount of RAM available. So you can say when the size of the RAM is increased, or when the capacity of the RAM is increased, the user can have more programs running in the background, or the user can work on multiple programs at the same time. Okay. So if you look at what I have also attached the marking scheme answer over here. Okay. So if you look at what the examiner expects from you, something like this, you should be able to say more applications can run at the same time because more instructions can be stored in the memory. So applications can run at a normal speed. It will not get stuck. It will not start lagging. Okay. Because if you have a small capacity of RAM, then what happens? Virtual memory is created. When virtual memory is created, computer becomes very, very slow. Okay, so these are some of the marking schemes answers. Okay, right. Next, we have another question. Jonas wants to buy a PC. He intends to use it to download music, watch videos, play computer games, communicate with friends. Okay, he plans to use the computer for these activities. Jonas has been advised that in order to complete these tasks, he will need a PC with a fast processor and a large amount of RAM. Explain, okay, guys, again, explain why Jonas has been advised to buy a computer with a large amount of RAM. Okay, a very similar question. This is from the 2012 past paper. So you should be able to go on to say with a large capacity of RAM, he will be able to have multiple programs opened at the same time. So virtual memory will not be created because virtual memory would definitely slow down the computer a lot. Now, if that is not enough, they're giving you 4 marks. You should also talk about the fact that he wants to play computer games. So computer games require instructions to be loaded quickly. There cannot be a delay, otherwise the game is not going to be playable, isn't it? So talk about computer games. You can also go further. Jonas intends to use it to play computer games. Computer games require instructions to be loaded quickly in a very short time. So him having a large amount of RAM would make it possible for the game instructions to be loaded quickly. Okay. And then you can also say, for example, he plans to watch videos. So videos also have graphical instructions that need to be processed quickly in a short time. Otherwise, the video is not going to play smoothly. You can also talk about that. Okay. So remember, guys, 4 marks and you have to explain. Okay. So I will also just show you what the examiner expects. Okay. What is the marking scheme expecting? So you can see they have spoken about the fact that games are large files. Games have lots of graphics. Okay, so over here, they have also spoken about multitasking, working on multiple programs at the same time. We call it multitasking. So for example, he's playing a game and in the background, he has a music being downloaded, for example. Okay, so this is what we call multitasking. Okay, so please do go through the marking scheme answers as well. Okay, right. Next, we move on to the next storage device that comes under primary memory. Okay, so under primary memory, guys, we have finished the first device. Okay, so we have completed ROM. Now we have completed RAM. Now we have to move into ROM. Okay, so I hope you have understood RAM. I hope it makes sense to you. The next thing that we will be moving on to is ROM, read-only memory. Okay, so we'll start that part in the next video. Okay, see you there.